All right, let's dive right in. We're tackling measures and accuracy today. Now, this is one of those topics from the GCSE higher tier spec that can be an absolute goldmine for marks, if you know the rules. But it can also be a real headache if you don't. So we're going to make sure you're definitely in that first group.
So, does this sound familiar? You've done all the really hard work, you've understood the question, but then a tiny slip up on rounding or, I don't know, finding a bound costs you those precious marks. It's got to be one of the most frustrating things in an exam, right? Well, today we're going to fix that.
And here's why it's so important. In the eyes of an examiner, this stuff isn't just about getting the right number on the page. No, it's about proving you have a much deeper understanding of what those numbers actually mean. When you nail accuracy, you're showing them you can think like a real mathematician.
And believe me, that's no exaggeration. The few marks you can pick up just by mastering these kinds of questions, that could literally be the difference between, say, a grade 7 and a grade 8. So our goal today is really simple. We're going to turn this tricky topic into a source of guaranteed marks for you in that exam.
Okay, so before we jump into the really tough calculations, we've got to make sure our foundations are rock solid. We'll start with the basics from N13 and N14 of the spec. Think of these as the essential building blocks for everything else we're going to cover.
First up, knowing your units. I know, it sounds super basic, right? But trust me, under exam pressure, you can't afford to waste a single second second-guessing how many meters are in a kilometer. You just need to know these conversions instantly without even thinking about it. Next, we've got estimation. And you should really think of this as your secret weapon. Seriously, before you even touch your calculator, just do a quick, rough calculation in your head. If your final answer comes out wildly different from your estimate, that's a huge red flag. It probably means you've just made a typo. It's such a simple sense check, and it can save you so many marks.
Okay, so our foundation is set. Now let's get to the real core skill, understanding error intervals. This is from N15, and honestly, this is where we start getting into the concepts that really separate the top grades from the rest.
So what on earth is an error interval? Well, think about it like this. When a measurement is rounded, let's say to 45 centimeters, we know that true value probably wasn't exactly 45, right? The error interval is just the range of all the possible values that number could have been before it got rounded.
Okay, let's look at a classic exam question to see what I mean. A piece of wood is 45 centimeters long, and it's measured to the nearest centimeter. Now, that phrase, to the nearest centimeter, that is the absolute key. It tells you exactly how you're going to find the bounds.
So here's how we write the answer. The rule is actually pretty simple. You take the unit you're rounding to, in this case, it's 1 centimeter, and you just go half a unit down and half a unit up. So that gives us 44.5 and 45.5. But you have to look really closely at those inequality signs. The true length, which we're calling L, can be equal to 44.5, but it must be strictly less than 45.5. And why is that? Well, think about it. If it was exactly 45.5, it would round up to 46, not down to 45.
And we give these two ends of the range special names, to make it official. The smallest possible value, that's the 44.5 centimeters in our example, we call that the lower bound.
And you guessed it, the value at the top end is the upper bound. But you've got to be really careful with the language here. The actual length can never be equal to 45.5. It just goes right up to it. That little distinction is absolutely vital if you want to get full marks.
All right, now for the main event. This is what it's all been building up to, using bounds and calculations. I can pretty much guarantee this topic will be on the higher tier papers, so mastering this is, well, it's non-negotiable.
Now, this idea right here, this is the single biggest thing that trips people up when it comes to calculations with bounds. It can feel totally backwards. But just think about a fraction for a second. To make a fraction as big as possible, you need the biggest number you can get on top and the smallest number you can get on the bottom. As soon as that little bit of logic clicks into place, you've basically cracked these questions.
Okay, let's put this into practice with a proper, meaty, exam-style problem. So, we're given a distance and a time. And notice, they're each measured to a different degree of accuracy. Our job is to find the upper bound for the speed.
So, how are we going to tackle this? Simple. We'll break it down. Step 1, let's find the bounds for the distance. It's 120 meters to two significant figures, which means its upper bound is 125. Easy enough. Step 2, find the bounds for the time. 5.8 seconds to 1 decimal place. That gives us a lower bound of 5.75. Now for step 3, the logic part.
To get the biggest, the maximum possible speed, we need to divide the maximum possible distance by the minimum possible time. See? It's that counterintuitive idea again. So we use the upper bound for distance and the lower bound for time. And then finally, we just plug those values right into our calculation. And that gives us our final answer. You pop 125 divided by 5.75 into the calculator, and you get 21.739 and a bunch of other numbers. Now, the question doesn't tell us where to round to, so giving it to 2 decimal places is a really sensible choice. So there it is. The upper bound for the speed is 21.74 meters per second.
Okay, this slide right here, this is about to become your new best friend. I'm not kidding. It summarizes every single combination you will ever need for doing calculations with bounds. Just look at subtraction and division. See how you have to mix and match the upper and lower bounds to get the biggest or smallest answer? You need to screenshot this, write it down, do whatever it takes to commit this to memory. This table is pure gold. We have covered a lot of ground. So let's boil it all down into a simple, straightforward checklist that you can run through every single time you see one of these questions pop up in your exam.
Okay, here it is. First, identify the degree of accuracy for every single value. Second, before you do anything else, write down the upper and lower bound for each one. Third, stop and think about which bounds you actually need to use. Remember that crazy division rule. Fourth, grab your cheat sheet, or just remember it, to pick the right calculation. And finally, give your answer to a sensible degree of accuracy. Just follow those steps and you honestly cannot go wrong.
All right, to finish things off, I've got a challenge question for you. Now this one's a bit of a beast. It combines a few different skills. You're going to need to calculate the maximum possible area and the minimum possible area, and then find the difference between them. So why not pause the explainer right here, give it a proper go, and really test yourself. You've got all the tools you need now. Good luck.